Switch statements are popular amongst programmers who are not familiar with object-oriented programming. So they're used to doing things in a procedural way, which means calling functions and functions and functions and passing arguments around. But in object-oriented programming, we think in objects as opposed to functions. And objects are about data and behavior, not just behavior. So in this video, we're going to take a look at switch statements, the problems with them, and how to refactor them using ReSharper in a safe way. You can find this example in the Solution Explorer under Switch Statements folder. Let's see what's happening here. We've got this class called monthly statement, which is used to generate the statement for the customers of a mobile or cell phone provider company. So it has a few properties here like call cost, SMS cost, and total cost. Here we have a generate method that takes a monthly usage object. Let's take a look at monthly usage. So in the monthly usage, we have properties such as customer, call minutes, and SMS count. Back to our monthly statement. So in the generate method, we do a switch on the usage.customer.type, and based on the type of customer, we have different rules. So if the customer is a pay-as-you-go customer, the cost of call is 12 cents times the number of minutes. The cost of SMS is 12 cents times the number of SMS messages. And finally, the total cost equals call cost plus SMS cost. But the rules are different for unlimited customers. They just pay a flat rate of 54.90 cents per month. And here we have a default statement, which is used if we send a different customer type that is not supported in the system. Now, what is the problem with this switch statement? Well, there are a couple of problems here. The first one is, if we want to add a new customer type, we have to come here and change this method. So we need to add a new case statement. Now, what is wrong with that? The problem is this method is going to be changed, which means the class that contains that has to be recompiled. And every other class in the application that is dependent on this class has to be recompiled and redeployed. And this cycle goes all the way up to the application root. If you have watched my course, C# Intermediate, Classes, Interfaces, and Object-Oriented Programming, there I talk about open-close principle, which means we want to design our software such that it's open to extension and closed to modification, which means we want to change the behavior of our software by adding new code, by adding new classes, as opposed to changing the existing code. Because every time we change something in the code, it is possible that we may break things along the way. So object orientation helps us design applications that are open to extension and close to modification. So this is the first problem. The second problem is, as we add new customer types here, this method is going to grow larger and larger and larger. Now, what you see here is an extremely simplified example. In a real-world application, we don't just calculate the cost for calls and SMS. We often have a lot more rules. Plus, there is another potential problem here. When we have switch statements based on the type of some object, it is quite possible that that switch statement is spread all over the application for different reasons. Sometimes we want to calculate cost based on the type of customer. Sometimes we may want to give them different promotions or vouchers. And as you see, we'll have different rules and all are based on the type of customer. So what is the solution to this problem? The solution is polymorphism. Now again, if you have watched my C# Intermediate course, you know what I mean by polymorphism. If not, in simple terms, that means instead of having one customer class, we're going to have a hierarchy of customers. So we're going to have a parent customer class and we're going to have derivatives. So something like a pay-as-you-go customer or unlimited customer. And we're going to push all this logic related to, say, pay-as-you-go customer inside that class. We're going to encapsulate those rules inside that pay-as-you-go customer. This way, we're not going to have a fat switch statement spread all over the application doing different things based on the type of the customer. Anything that is related on the type of customer can go in the class that properly represents that customer type. Okay, enough theory. Let's start refactoring and replace this switch statement with a polymorphic dispatch. But before we get started, I want to emphasize that when you're going to do big refactorings like what we're going to do in this lecture, make sure to have tests before doing your refactoring. If you're doing simple refactorings like changing the name of variables, changing signature, in most cases that's okay, you can get away with that. But if you're going to tear your classes apart and do big refactorings, you should always make sure to have tests that verify that the application is still working. Now for this simple example, I have written a couple of unit tests that you can find in Solution Explorer. Under cleancode.unittests, we've got a folder here, SwitchStatements, and here we have a unit test class called monthly statement tests. So pretty simple. We have a test case for pay-as-you-go customer, and what we're trying to validate here is that that customer is charged based on the sum of cost of calls and SMS. So we simply create a customer and give it that type. We set up some usage, and then we create a statement object and generate it based on that usage. And finally here we have 3 assertions against those values. Now if you're a bit more advanced, you probably know that we want to have a single assert per our unit tests. Now in this case, it's okay to have multiple asserts because this is one logical unit that we're testing. If you still prefer a single assert per test, that's perfectly fine. You can split this method into 3 test methods. But for this lecture, because we have limited time, we're just going to keep things simple. Now here is another test case for unlimited customers. And we want to test that they're charged a flat rate per month. So we create a customer, set its type to unlimited, set some usage here, and then create a statement and ask it to generate based on the usage. And finally, we're asserting that the call cost is 0, SMS cost is 0, and we just have a total cost of $54.90. All right, it's now time to start refactoring. So let's go to our monthly statement class. The first problem I see in this method is that we are too dependent on this usage variable, or more accurately, argument. So we go usage.customer.type, usage.callminutes, usage.smsCount. This method really likes that usage object, which makes me think this method really belongs to the usage class. And that's because of the encapsulation principle of object-oriented programming. Encapsulation says we want to have data and methods or operations that work on that data in the same class. The problem with this code is that we've got this usage class here, but the operation that is using the data in this class is not in that monthly usage class. It's in monthly statement. So the first thing we want to do here is to move this method to monthly usage class. So we put the cursor here. Control-Shift-R. Move instance method. Now look, even ReSharper knows that this method most likely belongs to the monthly usage class. So we're just going to select that. And I'm going to leave the access modifier as is. Next. Okay, this is gone. Let's take a look at monthly usage. We have a breaking change here because ReSharper could not figure out what to do with that switch statement. And that's why we get this red underline here. So now we are in the monthly usage, and in the monthly usage, we already know the customer. So we need to change this to customer.type. Okay, let's build the application. So far, so good. Before going any further, we want to run our tests and make sure everything is working. So we go to our unit tests and good. Okay, let's get back to our monthly usage class. After this refactoring, something is not right here. We're asking this generate method to generate a statement, but it gets that statement as an argument. It just doesn't make sense. We want the statement to be the output of this method, not the input. So we need to change its signature. So we put the cursor here, Control and F6. I'm going to change the return type from void to monthly statement. And I'm going to get rid of this monthly statement parameter that we are sending in. So this is what our method is going to look like. Generate, which returns a monthly statement. In fact, I like to change the method name to generate statement. This is more meaningful. we're asking the monthly usage class to generate a statement, not just generate. Generate what? Okay, now ReSharper could not work out what to do with this variable here. So you put the cursor here and note that red icon here. You can activate that by pressing Alt and Enter. The first item suggests to create local variable monthly statement. ReSharper does not know what type it should be, so it's suggesting object. We need to change it. Monthly statement. And of course, we need to instantiate it. There you go. And we need to change the method to return that object. Return monthly statement. Now, one thing I don't like here is this monthly statement is repeated twice. We can use the var keyword to make our code cleaner. So we put the cursor here, and ReSharper is already suggesting that with that yellow icon. So we press Alt and Enter and use var. Okay, that's better. And also, I would like to make this variable name shorter because it's obvious we are in the generate statement method and we're returning a monthly statement. So let's just call it statement. Let's noise in the code. Before going any further, let's build the application. Good, let's run our tests. They both failed. Let's see what's happening here. So it expected 12, but the result was 0. Let's take a look at the test code. So basically, here in the assert, we expected 12, but statement.callCost was 0. Why? Well, look here. We are creating the statement object, and by default, the value of that property is 0. We are not changing it. The problem happened after we changed the signature of generate statement. So this method is now returning a statement, which means we don't need to initialize that statement object here. So I'm going to get rid of this and assign statement to the return value of generate statement method. And I'm going to do the same here. Let's run our tests. Good. Now let's get back to our monthly usage class. Okay, this method is better than when we started, but there is still a problem here. We're still dependent on the type of customer to figure out what rules we're going to use. So we have two options here. One option is just to stick with it and accept this. Another option is to argue that this method most likely belongs to the customer class because the type is there and we want the operations that are based on that type to be there. So let's move this method one more time. So put the cursor here, Ctrl+Shift+R, move instance method. Look, now ReSharper is suggesting to move this method inside customer class. So let's select that. Gone. Let's go to the customer. Okay, the first problem is, again, ReSharper could not figure out how to change this expression here. So we are in the customer and we know the type. So we should just get rid of this system.type and just use type. Okay, now look, in the switch statement, we got rid of that expression that was usage.customer.type. But now we have this usage.usage.whatever. So you may argue, doesn't this method belong to the usage class? Well, yes, we can move it there because after all, for this operation to happen, to generate this statement, we need two pieces of data. One is the customer, one is the monthly usage. So we can put this method in either of these classes, but I prefer to put it here because now in the switch, I have only one single property that I'm making decision against, which means this is the right time for us to refactor this method into polymorphic dispatch. So instead of switching on type, we're going to have types that derive from customer. So before going any further, let's build the project and run our tests. Build is good. Let's go to the unit test. Beautiful. Now let's go to our tests. So essentially what we want to change here is instead of using the customer and setting its type to pay-as-you-go, we want to create a new pay-as-you-go customer. We can go in our code and create a new customer class, or we can start from test, more of TDD or test-driven development style. In this case, let's try a bit of TDD. So what I'm going to do is change this to pay-as-you-go customer and get rid of this initialization of type because we don't need it anymore. Of course, this class does not exist, so we put the cursor here and look the red icon here from ReSharper. So we activate it with Alt and Enter and ask ReSharper to create that class for us. Okay, ReSharper created that class inside our test file, but we have to move it to our production code, not the test code. So let's just go ahead with this. Enter, enter. Okay, now to move this, we can simply put the cursor here, Control-Shift-R, move to folder. Where do we want to move this for? So the target folder should be clean code, \. I'd like to put it in SwitchStatements because that's where we started. And I'm going to leave the rest as is. Good. Let's run this test again. The test broke. Look at the error message. Not supported exception. The current customer type is not supported. That exception was raised from GenerateStatement method in line 27. Let's go here. So looks like we got into this switch statement and neither of these cases were executed. So we got this exception. The reason for that is in our new customer class, which is pay-as-you-go customer, we forgot to set the type. So in the constructor, I set the type to pay-as-you-go. Let's run our test again. Beautiful. Now let's do the same thing with the other test method. Again, we're going to do it in a TDD style. So we're going to create a new class, unlimited customer. Alt and enter, 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 enter. We got a new class. Let's move it. Control-Shift-R, move to folder, clean code, / SwitchStatements. Beautiful. Now let's go to that file, unlimited customer. In the constructor, we'll set the type, unlimited. So the exact same step, nothing new. Back to our test. Let's run both of them. Beautiful. So now we have two new customer classes. Pay-as-you-go customer and unlimited customer. The last step here is to go to our original customer class and we're going to push this method down into both these subclasses because we want each of these subclasses to implement generate statement. So pay-as-you-go customer will implement this logic, whereas unlimited customer will implement this logic. And this is how we break down a fat switch block into polymorphic dispatch. So the logic will be encapsulated in derived classes. Okay, how do we push this member down? What we do, we put the cursor on the method, Control-Shift-R, and select push member down. So ReSharper knows we have two classes that derive from customer, pay-as-you-go and unlimited. We check both of them. And here is asking us what members of this customer class we would like to push down to subclasses. We just want to push generate statement. Now to make polymorphism happen, we need to make this abstract. Let's go ahead. So look, now our customer class has an abstract method called generate statement, and the implementation is in the derived classes. Let's go to pay-as-you-go customer. We have the exact copy of that method we had in the base class with the switch statement. And look at unlimited customer, the exact same scenario here. Before going any further and clean up the switch block, let's run our tests. Beautiful. Now let's go to pay-as-you-go customer. When we're inside this class, because we set the type to pay-as-you-go, only this block will be executed, right? So we're going to take this out, then select the switch block and delete it. We have a simple generate statement method with only a few lines that is only around pay-as-you-go customers. We're not mixing logic here. Let's do the same thing with unlimited customer. So in this class, this is the only statement that will be executed. Take it out, put it here, select the block and delete it. Now we run our test again. Excellent. Now one last thing. Let's take a look at this customer type enumeration that we had before. I can argue we no longer need this because now we have proper classes that derive from customer. How do we find out if we need this or not? We put the cursor on the property, press Alt and F7 to find usages. So we have two usages. One is in pay-as-you-go customer, in the constructor, look, it's here. And another one is in unlimited customer in the constructor. Well, I can argue we don't need this here, so let's just delete them and see if the test still pass. So I delete this from this constructor. Well, we can just remove the constructor itself. And do the same with unlimited customer. Let's run the test again. Great. So we didn't really need that property. Now let's go to customer again. So now this property is not used anywhere. We can safely delete that. So Ctrl+Shift+R and safe delete. Confirm, gone. Which means we don't need the enumeration anymore. Ctrl+Shift+R, safe delete. Excellent. And one last time, run our tests. Beautiful. So the lesson is, when you see a switch block that is based on type of something, always remember polymorphism. First, move that method to the right class, and finally, create subclasses and use the push member down refactoring to move the logic around. I hope you enjoyed this lecture, and thank you for watching.